In the profound, unblinking darkness a million miles from home, it floats in a state of perfect, frigid equilibrium. Here, at the second Lagrange point, the universe is a silent theater. The sun, the earth, and the moon are perpetually hidden behind a vast, five-layered shield, creating a permanent, artificial midnight. In this cold shadow, the James Webb Space Telescope waits. It is not an inert machine. It is a sentient extension of human curiosity, a patient predator hunting for the most elusive prey in the cosmos, ancient light. Its day does not begin with a sunrise, for there is none, but with a whisper. A stream of radio waves, having traveled for over 5 seconds across the void from Earth, arrives at its antenna. This is not a conversation, but a command. Encoded within this stream are the precise coordinates for its next quarry, a target chosen by scientists decades younger than the telescope's own conceptual design, a new question to be asked of the universe. The telescope's internal systems verify the command, and a slow, deliberate process begins. There is no sudden movement, no thrusters firing. Instead, internal reaction wheels, gyroscopic discs of metal, begin to spin, altering their momentum, with the silent, graceful precision of a leviathan turning in its sleep. The entire observatory pivots across the sky. The motion is imperceptible to a human eye, a glacial shift towards a new patch of darkness that, to Webb, is ablaze with untold stories. Its gaze settles upon a region that appears to other telescopes as little more than a dark smudge within the constellation of Orion. This is a stellar nursery, a cold, dense cloud of molecular hydrogen where new stars are being born. To a visible light telescope, it is an opaque curtain. To Webb, it is a translucent window. The Great Golden Eye, a honeycomb of 18 hexagonal mirrors working as one, begins its work. Its task is simple in concept and monumental in practice: to collect photons. For hours, it will simply stare, its instruments open and receptive. Photons that have traveled for hundreds of thousands of years from within that cloud now end their journey upon its gold-coated beryllium surface. These are not the bright, energetic photons of visible light, but the faint, stretched-out wavelengths of the infrared. They are messengers, carrying the thermal signature of creation itself. The faint warmth of collapsing protostars, the shock waves from stellar jets colliding with interstellar gas, and the dim glow of protoplanetary disks beginning to form worlds. All of this information is carried by the light. The light gathered by the vast primary mirror is funneled, focused onto a smaller secondary mirror, and then directed deep into the heart of the observatory, a module known as the Integrated Science Instrument Module, ISIM. This is the brain and the soul of the machine. Here, the light is not just photographed, it is dissected. Beams are split and passed through spectrographs, intricate devices that act like cosmic prisms. They spread the faint light into its constituent wavelengths, creating a barcode of information. Within this barcode, scientists on Earth can identify the chemical fingerprints of water ice-coating dust grains, the presence of complex organic molecules that are the precursors to life, and the precise temperature and density of the star-forming gas. The telescope is not just seeing, it is performing a remote chemical analysis on a crucible 5,000 trillion kilometers away. It is an act of forensic cosmology, piecing together the story of solar system formation by examining a new one in the process of being born. While one instrument captures a stunning, high-resolution image of the violent beauty within the cloud, another might be locked onto a single, specific star in the field. This star is known to host an exoplanet, a world orbiting a distant sun. As the planet passes in front of its star, a tiny fraction of the starlight filters through its atmosphere before continuing its journey to Webb. In that fleeting moment, the planet's atmosphere imprints its own signature onto the light. The spectrographs aboard Webb can detect these minuscule changes, revealing the composition of that alien air. The detection of methane, water vapor, or carbon dioxide in the atmosphere of a rocky, Earth-sized planet would be a discovery that would ripple through human history, and Webb is the first instrument with the power to make it. This dual capability, to capture both the grand, sweeping vistas and the minute, specific details, is what makes the observatory so revolutionary. After hours of silent gathering, the observation's complete. The raw data, a flood of billions of bits of information, is stored in the telescope's solid-state recorder. Now, the process reverses. The large antenna pivots not towards a star, but towards the faint blue marble in the sky a million miles away. A powerful, focused beam of radio waves transmits the data homeward. This stream of ones and zeros carries within it the image of a stellar nursery and the atmospheric composition of a new world. At the Space Telescope Science Institute in Baltimore, Maryland, this raw data is received. It is a cryptic message that must be decoded. Teams of scientists and software engineers run it through complex pipelines, calibrating for the detector's sensitivity, removing cosmic ray artifacts, and translating the numerical data into the colors and graphs that the human mind can comprehend. It is only here, back on Earth, that the work of the telescope truly culminates. The photon's journey ends on the mirror, the data's journey ends at the control center, but the journey of discovery is just beginning in the minds of the scientists who will now spend years, or even decades, analyzing what Webb has shown them. Having delivered its precious cargo, the telescope falls silent again, awaiting its next command, a patient sentinel continuing its lonely, vital watch in the cold, silent dark. It is a cycle of wonder, a testament to a species that, despite being bound to one small world, refuses to stop reaching for the dawn of the universe itself.